MIT researchers tracked 300 enterprise AI projects and found that 95% of them produced almost no measurable impact on the company's bottom line. The models functioned perfectly, yet the actual business operations stayed exactly as they were before the investment. Solving this disconnect is the primary function of a forward-deployed engineer. They're hired to lead with problem scoping, investigating the why of a project before writing a single line of code. Imagine a client asks you to implement AI in our factory. A standard engineering response is to immediately start thinking about technical architecture, wiring up frameworks like LangChain, or designing agentic workflows. Jumping directly into the technical build without understanding the floor-level friction is how multi-million-dollar AI initiatives end up stalling before they ever reach production. To prevent failure, you must guide a vague client request through a funnel that filters ambiguity into a technical specification. This starts with fundamental business questions. Is the goal to increase manufacturing yield, improve safety metrics, or reduce machine downtime? Clients often expect a fully autonomous factory floor. You must steer them back to their analog reality, managers drowning in handwritten paper logs. You find the real problem by asking the client to identify the single most time-consuming manual task their staff performs every day. In this scenario, a supervisor might spend 3 hours a day manually typing handwritten notes into an aging database. That specific, repetitive task is your solvable bottleneck. It is a narrow point of friction where a targeted AI tool generates immediate value. Only after this bottleneck is isolated and measured should an engineer begin designing the technical solution. Let's apply this to a new case. A hospital director asks you to use AI to reduce emergency room wait times. Before you consider the software, stop. Do not jump to a technical architecture yet. Pause the video and write down 3 clarifying questions you would ask the director to locate the actual cause of the delay. This habit of interrogating the problem before proposing a solution is the defining difference between a standard coder and a high-level forward-deployed engineer. If you immediately proposed an AI triage chatbot, you ignored the hospital's actual operational constraints. The professional approach is to first find the source of the wait. Is it a backlog in triage, a lack of available beds, or a delay in processing lab results? In many hospitals, you'll discover the bottleneck is actually administrative. Doctors spend hours waiting for medical records to be faxed and manually entered from other clinics. An AI tool that automates data extraction from those faxes solves the actual problem. By focusing on the why, you ensure that the how actually moves the needle for the business. Forward-deployed engineers take full ownership of the final business result. They stay with a project until the technical deployment solves the specific friction point they identified during scoping. Here's the framework for this mindset. Step 1. Catch the vague request. Step 2. Interrogate the problem by asking why. Step 3. Isolate the bottleneck with the highest return on investment. And Step 4. Build the solution. Mastering this process of problem decomposition is the fastest way to move from standard engineering into the most high-leverage roles in the AI industry.